You are standing outside on a clear night. Above you, the stars are scattered across the darkness, like someone threw a handful of salt at black cloth. They look permanent. They look eternal. They look, most importantly, like they have always been there. They haven't. Not a single star above your head existed for most of the universe's history. Not one. The universe is 13.8 billion years old. The oldest stars we can see are only about 13.2 billion years old. That means for roughly 600 million years longer than dinosaurs walked the Earth, the universe contained no stars at all. It was dark, completely dark, a black ocean with nothing burning in it. But here's what most people don't understand. That darkness was not empty. It was full. It was so impossibly full that if you could somehow exist in that time, existing itself would crush you. And before those first stars ignited, before that dark age began, there was something even stranger. There was a moment, not hours, not days, but fractions of a second when the entire universe, everything you can see, everything you can't see, all the galaxies and atoms and light, and you and me, was compressed into something so small you couldn't see it under a microscope. Smaller than that. Smaller than a grain of sand. Smaller than the period at the end of this sentence. Smaller than an atom. Smaller than the nucleus of an atom. So small that the word small stops meaning anything. This is not metaphor. This is not poetry. This is what physicists have mapped out through mathematics, so precise. It feels like reading the mind of God, and it means something profound. You are made of material that has been through something no human mind was built to understand. You are made of stardust that survived compression beyond all physical sense. You are holding in your hands right now, as you read this, atoms that were there at the beginning. When physicists talk about the Big Bang, they usually start with the universe at 1/1,000,000th of a second old. They call it the earliest moment they can seriously discuss. But physicists don't like to stop there. They push further back. What happened before 1/1,000,000th of a second? What happened at 1/1,000,000,000th of a second? At 1/1,000,000,000th? The answer is that time itself changes meaning. At temperatures of 10 septillion Kelvin, that's a 1 followed by 24 zeros, a number so large it doesn't correspond to anything in nature anymore. The laws of physics as we know them simply stop working. Gravity, which we think of as the fundamental force holding everything together, becomes indistinguishable from the other forces. It's not that we don't understand what's happening. It's that happening requires time to have the properties it has now, and time didn't have those properties then. The universe began not with a bang, but with a state of being so radically different from this moment that comparing them is like comparing a whale to the color blue. They're not just different sizes, they're different types of things. And we know this happened. We have evidence. We have seen the light it left behind. To understand how small the universe began, you have to start by understanding how big it is now. And to understand how big it is now, you have to stop thinking about size the way you normally do. When you look at the night sky, the stars seem scattered randomly. They're not. Every star is part of something larger. Our sun is one star among 100 billion others in the Milky Way. The Milky Way is a spiral galaxy, and it's so vast that light, traveling at 186,000 miles per second, takes 100,000 years to cross it from one side to the other. 100,000 years. That's not the time it would take you to drive there. That's not even the time it would take a spaceship. That's the time it takes light, the fastest thing that exists, to traverse the distance. If you left Earth right now, traveling at 20,000 miles per hour faster than any spacecraft humanity has ever built, you would reach the nearest star in about 70,000 years. Your great-great-great-great-grandchildren, multiplied across thousands of generations, would arrive. The Milky Way is one galaxy, and the universe contains at least 200 billion galaxies. 200 billion, each with 100 billion stars or more. That's at least 20 septillion stars. A septillion. If every person on Earth, all 8 billion of us, spent their entire lives counting stars without sleeping, without stopping, counting one star every second, it would take every human in existence 80 trillion years to count them all. The universe is only 13.8 billion years old, so we have stopped trying to count. We just measure light years and distance and accept that the scale is beyond human comprehension. We tell people the Andromeda Galaxy is 2.5 million light years away and expect them to feel small. And they do, but they don't feel small enough. Because here's the thing, Andromeda is the closest large galaxy to us. Everything else is further. Everything else is smaller in perspective, which means further away, which means we see it as it was in the past. When you look at a star 100 light years away, you are not seeing that star as it is. You are seeing it as it was 100 years ago. The light left that star when the Titanic sank. It has been traveling in the dark for a century. Now it hits your eye. Now you see it. The most distant objects we can see are galaxies that formed when the universe was only 300 million years old. We see them as they were. The light has been traveling toward us for 13.5 billion years. The universe has expanded so much that those galaxies are now 46 billion light years away, even though the universe itself is only 13.8 billion years old. The geometry of expansion creates a distance greater than the age of the universe multiplied by the speed of light. The space between us is being created as the light travels. You cannot escape it. You cannot picture it properly. No human brain evolved to understand this. Now pull back. Compress all of that. All 200 billion galaxies. All 20 septillion stars. All the dark matter and dark energy and light and everything we can measure. Imagine squeezing it down. Squeeze it smaller than a light year. Squeeze it smaller than the Earth. Squeeze it smaller than the Sunday. Smaller than Jupiter. Smaller. Smaller. Smaller than the moon. Smaller than a mountain. Smaller than a city. Smaller than you. Now you're at the size of a marble. Keep going. Orange. Apple. Sugar cube. Grain of sand. Keep going. The size of a dust speck. A bacterium. The point of a needle. An atom. Smaller than an atom. The nucleus of an atom is 100,000 times smaller than the atom itself. Almost all of an atom is empty space. Electrons floating in the void around a dense core. The universe fit inside something smaller than that nucleus. It fit inside something for which the word space has no meaning. The earliest moment physicists can describe mathematically is called the Planck time. It occurs 10⁻43 seconds after the Big Bang. That's 0.00000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000005 meters across. That's a decimal point followed by 34 zeros. That's a decimal point followed by 34 zeros, then a 1. To give you a sense of scale, a proton is enormous compared to the Planck scale. A human hair is incomprehensibly vast. If you enlarge the Planck scale to the size of a proton, you could fit 10 billion protons across the observable universe. The scale is so small that quantum mechanics, which describes reality at the atomic level, breaks down. Reality itself breaks down. At this scale, in this first instant, quantum fluctuations tiny, random variations in the fields that underlie reality could have created everything. A physicist named Alex Valenkin has suggested that the universe might have come from literally nothing, triggered by quantum mechanics. The vacuum of empty space, quantum mechanically speaking, is not empty. It's boiling with virtual particles. Energy fluctuates in and out of existence. Perhaps a fluctuation large enough triggered time and space themselves. We don't know. We may never know. But we know what happened next. The universe began to expand, incredibly fast. In the first trillionth of a second, it grew by a factor of 10, 26. Incomprehensibly fast expansion, called inflation. Space itself stretched, and in doing so, it pulled apart virtual particles, converting their energy into the real energy that would later become matter and light. It stretched so violently that the universe became smooth, homogeneous. Physicists call it the same everywhere, but not quite the same. Quantum fluctuations left tiny ripples in the density of this expanding universe. Regions that were microscopically denser than others. Infinitesimal variations encoded by quantum mechanics in the fabric of space itself. Those variations would become galaxies. Those ripples in the fabric of the universe at 10, -35 meters across would eventually pull matter together and form 200 billion galaxies. You are made of matter that formed from those ripples. Your atoms were created in the hearts of stars that formed from those quantum fluctuations. The calcium in your bones. The iron in your blood. The oxygen you breathe. All of it traced backward through 13.8 billion years of history, to those infinitesimal variations in a universe smaller than an atom. Then the universe cooled. In the first microsecond, quarks froze into protons and neutrons. In the first second, the universe was no longer hot enough for protons and neutrons to convert into each other the nuclear forces locked in place. In the first 3 minutes, neutrons and protons fused into nuclei, the cores of atoms, hydrogen, helium, trace amounts of lithium. That was it. After 3 minutes, the universe had created the building blocks for everything that would ever exist. For 380,000 years, the universe remained opaque. Hot plasma. Photons bouncing off free electrons, unable to travel far. Then came the moment of recombination. The universe cooled enough that electrons could attach to nuclei. Atoms formed, and suddenly, for the first time, light could travel. The universe became transparent. The light from this moment is still traveling toward us. We detect it as the cosmic microwave background. We see the universe as it was 380,000 years old. We see the ripples, those quantum fluctuations encoded in the early universe. We see them now as tiny temperature variations in this ancient light. Variations of 1 part in 100,000. Infinitesimal wrinkles. Those wrinkles became you. The question, what came before the Big Bang, is not a scientific question. It's a philosophical one. Physics ends at the boundary of time. Time itself begins with the Big Bang. Before requires time. So the question contains an impossible requirement. It asks us to imagine a moment before moments were invented. Some physicists think time is cyclic. Maybe the universe expands, then contracts, then expands again. An endless series of universes, each one born from the previous. Others think there might be multiple universes existing in parallel, each with different laws of physics. Our universe, the one with laws that allow gravity, stars, chemistry, life, might be just one possibility among infinite others. We don't know. Maybe we can't know. But here's what we do know. The universe began very small, impossibly small. And in that instant, in that compressed state, all the information that would become galaxies and stars and you was already present, encoded in quantum fields, waiting. When you look at your hand, you are looking at an arrangement of atoms. Specific atoms in specific positions. That arrangement is remarkable. It's conscious. It's alive. It's capable of understanding the universe it came from. The odds of your hand existing are infinitesimal. Not just because you had to be born, which required trillions of coincidences, but because the universe itself had to be the way it is. If the strength of the strong nuclear force were 1% different, stars wouldn't form. If gravity were slightly stronger, stars would collapse before nuclear fusion could begin. If gravity were slightly weaker, stars would never form at all. The universe appears fine-tuned, specifically tuned to allow atoms to exist, stars to form, planets to coalesce, and on at least one planet, chemistry to become complex enough to spark life. Some physicists call this the anthropic principle. We observe the universe to be fine-tuned for life, because if it weren't, we wouldn't be here to observe it. But that's not comforting. It's the opposite. Because if the universe is this finely balanced, and it was triggered by quantum mechanics, by randomness at the smallest scales, then your existence is like this. Someone threw dice at infinity, and they landed in exactly the right way to create you. Not just you. Everything. Every human who has ever lived. Every person you love. The sound of waves. The way light moves through water. All of it came from dice thrown at infinity. The universe doesn't care about you. It will not care about you after you're gone. In 100 years, no one who knows you will be alive. In 1,000 years, not a single atom of your body will be in the same place. In 1 trillion years, the stars will have burned out. In 10 trillion years, all matter, as we understand it, will decay. In the incomprehensibly distant future, the universe will reach a state called heat-death maximum entropy. Everything will be spread so thin, so evenly distributed, that nothing will happen. No energy gradients, no change, just infinite cold and infinite darkness. The universe will not remember you. And yet, you are made of material that survived the greatest violence imaginable. You are an arrangement of atoms that has the peculiar property of being able to understand its own origin. You can look up at the sky and think about infinity. You can comprehend, however dimly, the journey your atoms took from the first, second, to now. That's not nothing. That's everything. The vast majority of matter in the universe has no idea how it got here. A rock has no idea. An ocean has no idea. But you do. Somehow, through an arrangement of carbon and nitrogen and oxygen, you became aware. You became conscious. That consciousness is perhaps the rarest and most fragile thing in the universe. And it will end. Your consciousness will end. All human consciousness will end. All life on Earth will end. When the sun becomes a red giant and boils away the oceans, the Earth itself will end. When the sun dies, our galaxy will eventually collide with Andromeda. The combined galaxy will eventually be torn apart by the expansion of the universe. Everything you care about will cease to exist. But in this moment, this exact moment, now, as you read these words, you are aware. You are conscious. You are made of stardust arranged in a way that can contemplate the stars. Your atoms were there at the beginning. They saw the universe transform from smaller than an atom to a space so vast that it breaks human comprehension. They were in the hearts of stars that died to birth your atoms. They were in the dust clouds that collapsed to form our solar system. They were in the primordial soup where chemistry became biology. And then one day, by an almost impossible coincidence of timing and place and random molecular movement, those atoms arranged themselves in a way that could think, could wonder, could suffer, and laugh, and love. The universe is 13.8 billion years old. For the first 600 million years, it was completely dark. For most of its history, nothing alive has been in it. And then, in what is less than the blink of an eye cosmically speaking, on one small planet orbiting a medium-sized star in a minor galaxy, atoms became conscious. That is not something the universe cares about. But maybe it should.